day, everyone!
In this section, we will present a generalized version of simplex method that will solve both maximization and minimization problems with any combinations of lesser than or equal to, greater than or equal to, and equal constraints. And this process is called Big M method.
But before getting the basic feasible solution using the Big M method, we will first present the steps that you must consider.
Are you guys ready? Let's do this.
Multiply the inequality constraints to ensure that the right-hand side is positive. For example, our constraint is x sub 1 plus 3x sub 2 greater or equal to negative 19. As you can see, we have a negative number on the right-hand side, so we must multiply it with a negative 1. Then the result will be negative x sub 1 minus 3x sub 2. Then since we multiply a negative number, we must also change the inequality. Therefore, it is now lesser or equal to 19. So now therefore we have the positive on the right hand side. Then there you go.
Step 2. For any greater than or equal constraint, we will introduce surplus and artificial variables. Step 3. For any less than constraints, we will introduce slacks variables. And step 4. For any equal constraints, we will add artificial variables. So, greater than which we will add surplus and artificial variables, then less than for slacks variables and equal for artificial variables. Let's say, for example, we have mixed constraints which has less than constraints, greater than constraints, and the equality constraints. So, here, in less than constraints, we add slacks variables. And the second constraints, we subtract surplus variable and add artificial variables. And the last one is the equality sign, which we add artificial variable. So, as you can see, they are all in equal sign constraints. And this is the standard form of the constraints.
Step 5. For any artificial variable, we must multiply negative m and add it to the objective function. For example, maximize 3x sub 1 plus 2x sub 2, and the standard form of its constraints are x sub 1 plus 3x sub 2 plus s sub 1 is equal to 150, 2x sub 1 plus 4x sub 2 plus minus s sub 1 plus a sub 1 is equal to 100, and x sub 1 plus x sub 2 plus a sub 2 is equal to 50. And as you can see, there are two artificial variables. And go back to the step, we must multiply negative m to it and add it to the objective function. So, we have z is equal to 3x sub 1 plus 2x sub 2 minus ma sub 1 minus ma sub 2 because our problem is maximization. So, we have two artificial variables and we add it to the objective function, which is this one. And now, we are ready to solve linear programming problems using the Big M method.
Good day, everyone. So today we're gonna talk about the Big M method. Now, when does the Big M method can be utilized to use in solving the optimal solution of the problem? Now, in Big M method, we cannot simply proceed to the simplex method routine like we used to do. Now, in order to make a simplex method, we must add artificial variables. And this is artificial variables is a violation in performing the simplex method in the linear programming. That's why we are assigning a very large number in which it is denoted by negative m for maximization and positive m for minimization problem. Let's have an example problem. Now, here's the problem. Maximize z is equal to x sub 1 minus x sub 2 plus 3x sub 3. X sub 1 plus x sub 2 is less than or equal to 20, and x sub 1 plus x sub 3 is equal to 5, and x sub 2 plus x sub 3 is greater than or equal to 10, wherein x sub 1, x sub 2, x sub 3 is greater than or equal to 0. Here you notice that the sign of inequality and equality are different, right? Now, that's why we cannot simply use the simplex method in getting the optimal solution of the problem. Now, here's the solution. We must transform the problem into its standard form. Now, like I said a while ago, that we must add slacks variables and the artificial variables, wherein we're assigning the very large number, which is called m. That's why this is called the big M method. Okay. So, yeah.
Wala siya.
Now, here is the standard form of the problem. Now you will notice it that this constraints is less than and equal to 20. So we must add a slacks variable to make it equal to 20. And for the second constraints, you can notice that it has an equal sign. So we must add in artificial variable. For the third constraints, you can see that it is greater than or equal to. That's why we must subtract a surplus variable and we must add a slacks or an artificial variable to make it equal to 10. Now, since we are adding here in artificial variable, two artificial variable in the maximization problem, we must also subtract, wherein you are assigning a very large number here as its coefficient. So the rule can be balanced. Since we are finished in transforming the problem into its standard form, now by using this, we're ready to proceed in the simplex method algorithm. Now we can use this one as our tableau.
To make our first tableau, we use the what we learned about simplex method in getting the matrix, making the matrix here. So first tableau is, here is the first constraints, wherein x sub 1 is, the coefficient of x sub 1 is 1, the coefficient of x sub 2 is 1, x sub 3 is no, is 0, then 0, and s sub 1 is 1. There is no s sub 2, a sub 1, and a sub 2 and z, and is equal to 20. Now the second constraints, x sub 1, the coefficient is 1, x sub 2, there is nothing, x sub 3 is 1, s sub 1 is nothing, s sub 2 also nothing, a sub 1 is 1 and equal to 5. Now, for a sub 2, I mean for the third constraints, x sub 1 is, there is no x sub 1, so we leave it 0. X sub 2 is 1, x sub 3 1, there is no s sub 1, s sub 2 is negative 1, a sub 1 is, there is no, that is 0, and a sub 2 is 1 and is equal to 10. Now at the bottom part, we know already how to make it included in the tableau. We must transpose it to the opposite side. Now that's why x sub 1 will be negative 1, x sub 2 will be, the coefficient is negative 1, so it will become positive 1, and negative 3. And since we put in an artificial variable to the m, wherein the coefficient of the artificial variable a sub 1 and a sub 2 is the m, wherein it is the largest negative number, so we must put it here at the m. A in the 0, it is a sub 1, here is m as the coefficient, a sub 2, here is m as the coefficient, z is 1, and the basic possible solution is equal to 0 since there is nothing left at the right side of the equation. So let's proceed to the, now since the first step in symmetric method algorithm is choose the largest at the bottom, you will choose at the bottom which has the largest negativity. So since m is a very large negative number, so it's either in the two of them will you choose the entering variable, and you will choose later on the departing variable. Now it's either you will choose first this column or this column. Now let's assume that we use this first column here in the a sub 1 column. Now there is nothing we can use as departing variable, which is this one at the row 2 and the column of a sub 1. So here's our departing variable. Because this is 0, this is 0, we can get a ratio of that, so we'll choose this. Now we want it to make it 0 because that is the simplex algorithm method. Now we want it to make it 0, that's why we perform a basic row operation, which negative m times r2 here plus r4, which will become r4, so that only the row 4 will be changed in the process. Now this is our second tableau after performing the row operation. Here it is. Okay, now here we perform a basic operation to make it 0, and by performing that, this one will be changed at negative m. This one will be negative m times r2 is negative m minus plus r4, which is negative 1, so negative m minus 1. Now because the column x sub 2 and the row 2 is 0, it won't be changed because negative m times 0 is 0 plus 4 is still 1, so there is nothing we can do with that. Now here, because it has a value which is 1, no, negative m times row 2 is negative m minus plus negative 3 is negative 3 here, so we get this value here. It is negative m minus 3. Now this column here won't be affected, this also won't be affected, and this will become 0. As you can see, this m here will become 0 because we perform row operation, and this column here won't be affected because it has a 0 value here, and also here, and this column at the basic simple solution column. Now here is our basic variables, which is x sub 2 is equal to 5, x sub 3 is also equal to 5, z is the value of z, which is our maximization problem of the value, so it's equal to 10. And our S sub 1 is equal to 15, which is our stocks variables. We must include it 1 to our basic variables because it can affect the equation in our standard form. In the non-basic variables are x sub 1, s sub 2, a sub 1, and a sub 2, which won't affect the equation. Now, since we perform it, the bigger method, so this is the big M method. So the big M method is actually a simplex method wherein you use the M here as your large number to get the answer, because in simplex method you can only solve it when the constraints are homogeneous, but in big M method you can answer it when the constraints are in greater than or less than 2, or it is mixed. Okay.
You guys learned out from this example. For more questions, kindly write it down in the comment sections below and subscribe to our channel for more video tutorials. Thank you, goodbye, see ya!